Okay, so section 8.4, this is about Lagrange multipliers. So basically you want to minimize or maximize a function given a side condition. So an example of how this would come into play is that you have this budget for a company that allows for a total of $20,000 for labor and capital to produce a certain product, where the labor units cost a certain amount and capital costs a certain amount. So the production function has this thing, and then you want to figure out how to determine the budget while taking into account the labor and the capital that would maximize production. So this is like, it is confusing. So you have this like curve, this side condition, and you want to look at how your function is changing with respect to both variables along that curve. So like this is real world stuff, right? You have this company that has this production function, and you also need to maximize that production, but stay within their allocated or available costs for labor and capital. So the way that we're going to do this is by creating and optimizing a new function. So this is a method to do this. Is called Lagrange multipliers. So you have the side condition, which is a restraint. And in the example we were just looking at, that side condition is the amount of money that they can spend on labor and capital. So we would create this new function, f of x, y, and lambda. That third variable is lambda. So you're going to do whatever your function is. So in this case, that was the production costs for this company. So that function, and then plus lambda times your restraint, whatever the restraint function that is given to you. So let's do an example to try to solidify that. So we want to find the minimum of x squared plus y squared subject to this restraint that x plus y minus 4 is 0. Excuse me. So we want to form this new function, big F of x, y, and lambda. So we're going to do f of x, y minus lambda times g of x. So this is g of x equals 0. That's this is g of x. So we have x squared plus y squared minus lambda times x plus y minus 4. So we're looking at x squared plus y squared minus lambda x minus lambda y plus 4 times lambda. Okay, so if there is a minimum to this thing, what's true about a minimum of a function? That the derivative is 0, right? So in this case, each partial derivative, it has to be 0. That's the slope of the tangent plane now. So how we're going to do this is find the partials and set them both equal to 0. So we're going to do big F sub x and big F sub y. So if I take the partial of this thing with respect to x, I have 2x plus 0 minus lambda minus 0 minus 0. And if I do the partial with respect to y, I would have 2y, well, 0, and then 2y, and then 0, and then negative lambda, and then 0. So I have that f sub x is 2x plus lambda, f sub y is 2y plus lambda. For a minimum, I need these to both be 0. That means that I am looking at lambda equals, actually, let's solve this one for lambda. So we have lambda equals 2x. And then we're going to take this and plug it into the lambda over here. So we have 2y minus 2x equals 0. And that means that 2y equals 2x, so y equals x. Okay, so then you're going to use that in your g of x equation. So g of x, remember, is that 0 equals x plus y minus 4. And we know that y equals x. So we have 0 equals x plus x minus 4. So we have 4 equals 2x, and then we have that x equals 2. And if x equals 2 and y equals x, then y also equals 2. So 2, 2 would be the minimum here. Okay. And then you want to plug back in, right, this is where the minimum happens. We need to figure out the function value there. So we're going to do f of 2, 2. So that would be 2 squared plus 2 squared, which is 8. So 8 is the minimum of that function. Okay, so let's try this again. So we have this f of xy is equal to 6x squared plus 5y squared minus xy. And we're subject to this restraint now of 2x plus y equals 24. So we're going to do 2x plus y minus 24 equals 0. This is our g of x. So big F of xy is going to be little f of xy minus lambda times g of x. So we have 6x squared plus 5y squared minus xy minus lambda times 2x plus y minus 24. So I'm going to go ahead and simplify this, or expand that, I guess. My lambdas and my x's are going to start to look similar here. Minus y times lambda plus 24 lambda. All right, so f sub x is going to be 12x plus 0 minus y minus 2x minus 0 minus 0. F sub y, so this is partial derivative stuff from 8.2. So f sub y here would be 10y minus x minus y. Oh, lambda, I mean. Oh goodness, this is lambda. Let's see. 12x, 0, negative y. Negative 2 lambda. Zero on 0. Okay. Now in terms of y, 0, 10y, negative x, 0, negative lambda, and then 0. So we're going to do the same kind of thing here. We're going to solve one of these for lambda. We want these to both be 0. Because again, to find a minimum or a maximum, you want the derivative to be 0. Here we want both partial derivatives to be 0. So we're looking at, on this one, let's do 12x minus y minus 2 lambda equals 0. And 10y minus x minus lambda equals 0. I'm going to solve this one for lambda. So 10y minus x equals lambda. I'm going to plug this in to lambda because I need to solve this system. So there's not a lot of space here. So I'm going to take all of this and move up here. So I have, when I plug that in, I have 12x minus y minus 2 times lambda. Lambda now is 10y minus x. This equals 0. So I have 12x minus y minus 20y plus 2x equals 0. So what's that? 14x minus 21y equals 0. So I'm going to get 14x equals 21y. I'm going to divide by 14. So x equals, what's that, 3/2 y? And then we're going to take this and plug into g. So we'll do g of x. Well, we'll plug it into the restraint. So 2x plus y equals 24. So 2 times 3/2 y plus y equals 24. So 3y plus y is 4y. So y is 6. And then you want to do, there's just so much going on. you want to do big F of x is 3/2 y. Okay, that's 9. So you want to do F of 9, 6 to actually figure out what we're minimizing here. And when you do that, you get 612. So that is your actual minimum. There's a lot of steps here, right? So find big F, take the partial derivative, set them equal to 0. Either solve for lambda in both and set them equal, or solve for lambda in one and plug it into the other. Get that system, solve it for one of the variables, and then plug into your restraint to get the other variable. Then you have an ordered pair, in this case 9, 6. You're going to plug in to F to find the actual minimum value. So let's do it again. We have this function f of xy is 8xy minus 3x squared, and we have the restraint that's going to be x plus 2y minus 14 is 0. So big F is going to be 8xy minus 3x squared minus lambda times x plus 2y minus 14. So this is 8xy minus 3x minus lambda x minus 2 lambda y plus 14 lambda. All right, then we're going to do partial derivative. So f sub x is going to be 8y minus 6x minus lambda. F sub y is going to be 8x minus 0 minus 0 minus 2 lambda. And then we want to set these equal to 0. So we have 8y minus 6x minus lambda equals 0. And then we have 8x minus 2 lambda equals 0. So I'm going to solve this one for lambda. So I have 8x equals 2 lambda. So 4x equals lambda. Then I'm going to take this and plug it into this equation. Okay, so then we have 8y minus 6x minus 4x equals 0. So 8y is equal to 10x. So then y is going to be 10 over 8 times x, which is what, 5/4 x. Okay, and then we're going to use g to get y now. So we have x plus 2 times y, which is 5/4 x equals 14. So x plus 10/4 x equals 14. That's 14/4 x equals 14. Multiply both sides by, well, multiply by 4 over 14. So we have x equals 4. And then if y is 5/4 x, we're looking at 5/4 times 4, so 5. So you want to plug in 4, 5 into f. So f of 4, 5, this is a little f to get the minimum or maximum. And when you do that, you have 8 times 4 times 5 minus 3 times 4 squared. This is 112. All right. Let's do number 3, and then I think we can probably call it, because all of these are pretty much the same kind of example. So let's just do one more and then we'll call it. I'll have some numbers marked for you guys to skip, and I will tell you which ones those are. So let's just do number 3 and then we'll call it. So a company has a plant in Los Angeles and a plant in Oklahoma City. The firm is committed to produce a total of 40 units of product each week. The cost function is given to us. X is the number of units produced in LA, and Y is the number of units produced in Oklahoma City. So how many units should be produced in each plant to minimize weekly cost? So we're going to figure out our, the restraint is, we have to figure that out, right? So since the firm is committed to producing 40 units, that means the units produced in LA plus the units produced in OKC needs to equal 40. This is our restraint. So we are going to have that X plus Y minus 40 is 0. So that's our restraint. So our big function f of xy is going to be this c of xy, so 0.3 x squared plus 0.2 y squared plus 20x plus 7y plus 200 minus lambda times x plus y minus 40. So okay, so we're going to take the partial derivatives. So f sub x is going to be 0.6x plus 0 plus 20 plus 0 plus 0 minus lambda minus 0 minus 0. F sub y would be 0.4y plus 7 minus lambda. All right, and then I'm going to solve, we need them to both be equal to 0 and solve the system. So we're going to have 0 equals 0.4y plus 7 minus lambda, and 0 equals 0.6x plus 20 minus lambda. So you can see that you would have lambda equals 0.4y plus 7 and lambda equals, so you can just do that and plug that in. Oh man. So we're going to take this and plug it in for lambda here. So we have 0 equals 0.6x plus 20. Is that 20? Yes. Okay. 0.6x plus 20 minus lambda, which is now 0.4y, and then minus 7. So we're going to solve this thing. So we have 20 minus 7 is 13. So 0 equals 13 plus 0.6x minus 0.4y. So we have gross. So I'm going to move this. So negative 0.6x equals 13 minus 0.4y. And then I'm going to divide by negative 0.6. So I have x equals negative 65 over 3 plus 2/3 y. And then I'm going to use this in G. So we have x plus y is 40. Or x plus y minus 0, minus 40 is 0. So x plus y is 40. So we have 65, negative 65 thirds plus 2/3 y, plus y is 40. So negative 65 thirds. What if I just multiply everything by 3? This is going to make life easier. So negative 65 plus 2y plus 3y equals 120. So that's 185. 2y plus 3y is 185. So 5y is 185. So y is 37. Ugh. That means that x is 3. Does that work? Negative 65 thirds. Plus 2. What is 37 times 2? 74 divided by 3. Ugh, where's my real calculator? So we have negative 65 thirds plus 2/3 times 37. 3. Yep, that's good. All right. So then we're gonna do our cost to actually figure out how many units should produce and so how many units, this would be 37 in OKC and 3 in LA. And the minimum cost, you would do C of 337. Okay, so the rest of them are kind of similar to this. I have notes to skip this problem and to skip this one. So go for that and let me know what all you guys need help with. I will hopefully hear from you soon.